Good morning all. So let us look at the next indeterminate form in today's class. So that is of the type 0 into infinity. Now when you have the indeterminate form of the form 0 into infinity, so what we do is we'll convert it into either 0 by 0 or infinity by infinity. അപ്പോൾ നമുക്ക് അതിനെ റീറൈറ്റ് ചെയ്ത് ആ പ്രൊഡക്റ്റിനെ നമുക്ക് 0 by 0 ഫോമിലേക്കോ infinity by infinity ഫോമിലേക്കോ കൊണ്ടുവരാൻ പറ്റും. And then use the 0 by 0 or infinity by infinity form to obtain the value of the limit. അത് നമ്മൾ കഴിഞ്ഞ ക്ലാസ്സിൽ കണ്ട പോലെ തന്നെ. Okay. So let us see a few problems on 0 into infinity type. So evaluate the following limits. So first one is limit x tends to 0 plus x ln x. So ഇനി നമ്മൾ 0 into infinity form എന്ന് പറയുമ്പോൾ this infinity that can be either plus infinity or minus infinity. So this is in the form, so as x approaches to 0, so you will have 0 into, so when you take limit of ln x approaching to 0 plus, that will be minus infinity. So it is in the form 0 into infinity form. So let us rewrite it as limit x tends to 0 plus, so I'm going to write it as ln of x by 1 by x. Now this reduces to the infinity by infinity form. So by applying L'Hospital rule for infinity by infinity form, so this will be equal to limit x tends to 0 plus, so this is 1 by x by minus 1 by x square. So that is going to be limit x tends to 0 minus x square by x verum. So that will be limit x tends to 0 plus x cancel out, so that is minus x, so which is equal to 0. So therefore the limit is equal to 0. Let us see another example. Limit x tends to pi by 4 1 minus tan x into sec 2x. So tan pi by 4 is 1, so that is 0. First term will be 0, and sec 2x വരുമ്പോൾ sec pi by 2 വരും, that will be infinity. So this can be written as limit x tends to pi by 4 1 minus tan x by cos 2x എന്ന് നമുക്ക് എഴുതാൻ പറ്റും. So that will be 0 by cos pi by 2 എടുക്കുമ്പോൾ cos pi by 2 will be 0. So this is in 0 by 0 form. So upon applying the L'Hospital rule, so you will get minus sec square x by minus 2 sine 2x. So again applying the limit, so this is by using the L'Hospital rule. Now apply the limit, so you will get minus sec square pi by 4 by minus 2 sine pi by 2 വരും. So cos pi by 4 is 1 by root 2, so you will get minus 2 varum by minus 2, so value is equal to 1. And next is limit x tends to infinity x e raised to minus x. So this is in infinity into 0 form, so that is so you can rewrite it as x by e raised to x, so which is in infinity by infinity form. So by L'Hospital rule, that will be limit taking the derivative on numerator and denominator 1 by e raised to x, so this is by L'Hospital rule. Now this is 1 by infinity, 1 by infinity will be 0, so value of limit will be equal to 0. And next is limit x tends to infinity x sine pi by x. Again this is infinity into now pi by infinity is 0, so sine 0 is 0, so infinity into 0, so that is rewritten as, so you can write it as sine pi by x by 1 by x. So taking the derivative, so applying L'Hospital rule, so you get limit x tends to infinity cos pi by x into minus pi by x square by minus 1 by x square by L'Hospital rule. So that will be equal to limit x tends to infinity, 1 minus 1 by x square cancel out, so pi cos pi by x. Now cos 0 is, so this will be 0, so cos 0 is 1, so you will get pi. And next question is, so find limit x tends to 0 plus tan x into ln x. So that is again 0 into infinity form. So this can be rewritten as limit x tends to 0 plus ln x by cot x. So that will be in 0 by 0 form. So taking the L'Hospital rule, we will get 1 by x by cot x into minus cosec square x varum. So that will be limit x tends to 0 plus, so that is minus again sine square x by x varum. So again it is in 0 by 0 form, so this is by L'Hospital rule. So again applying the L'Hospital rule, so you will get minus 2 sin x cos x by 1, so the limit will be equal to 0. So those are a few examples of the 0 into infinity form. Now let us look at the next type of indeterminate form. So next is the indeterminate form of type infinity minus infinity. And now when you take infinity minus infinity form, that can be of different types. നമുക്ക് plus infinity minus infinity വരാം. അപ്പോൾ അതിനനുസരിച്ച് നമുക്ക് ഈ same form തന്നെ നമുക്ക് different forms വരും. Now a limit problem that leads to one of the expressions. So when you have these type of expressions, so you have plus infinity minus plus infinity and minus infinity minus minus infinity, then you have minus infinity plus infinity plus minus infinity, and then you have minus infinity plus infinity. So only these 4 types of expressions are called indeterminate forms. So these are called an indeterminate form of type infinity minus infinity. If these expressions, the expressions ഇനി നമ്മൾ പ്ലസ് ഇൻഫിനിറ്റിയുടെയും മൈനസ് ഇൻഫിനിറ്റിയുടെയും ഡിഫറെന്റ് കോമ്പിനേഷൻസ് എടുക്കുമ്പോൾ യു ക്യാൻ ഗെറ്റ് ദീസ് എക്സ്പ്രഷൻസ് പ്ലസ് ഇൻഫിനിറ്റി പ്ലസ് ഇൻഫിനിറ്റി ആൻഡ് പ്ലസ് ഇൻഫിനിറ്റി minus infinity, then you can have minus infinity plus minus infinity, and you can have minus infinity minus plus infinity. So nammal other term it is plus infinity plus infinity. So this entire term will be going to infinity, and here again plus infinity, idum plus infinity ആയിരിക്കും വരിക. അപ്പോൾ ഇവിടെ രണ്ടും minus infinity, that will be going to a very small number. So this is also going to a very small number. So these expressions are not indeterminate. So only the above forms. So namukku plus infinity minus plus infinity, that's not defined, then minus infinity minus minus infinity, then plus infinity plus minus infinity, and minus infinity plus plus infinity. These are only the indeterminate form, which is of the type infinity minus infinity, and the L'Hospital rule works only for this type of problems. Okay, and now നമ്മൾ ഇനി എങ്ങനെയാണ് L'Hospital rule apply ചെയ്തതെന്ന് നോക്കാം. So L'Hospital rule apply ചെയ്യാൻ വേണ്ടി what we do is, so given an expression of infinity minus infinity type, we need to simplify it into either 0 by 0 or infinity by infinity form. എന്നിട്ട് നമ്മൾ 0 by 0 infinity by infinity ചെയ്യുന്ന പോലെയാണ് നമ്മൾ സോൾവ് ചെയ്യുക. So let us look at few examples. So we'll do an example. So first is evaluate. Okay, so evaluate the following limits. So find limit x tends to 0 plus 1 by x minus 1 by sin x. So that will be limit x tends to 0 plus, so we can take the common denominator, so that will give sin x minus x by x sin x. So you can see that it is in 0 by 0 form. So upon applying the L'Hospital rule, so you will get cos x minus 1 by x cos x plus sin x. So again it is in 0 by 0 form. So apply the L'Hospital rule once again. So that will give limit x tends to 0 plus, so numerator you will have minus sin x, and in denominator you will have x cos x plus sin x in the derivative. So that will be cos x minus x sin x plus cos x. So that will be equal to, so when you apply the limit you will get minus 0 by 2 minus 0. So the value is going to be equal to 0. So that is the value of the limit. And next is limit x tends to 0 1 by x square minus cos 3x by x square. So that is again in infinity minus infinity form. Okay, so here it is again infinity minus infinity form. നിങ്ങൾ എല്ലാ പ്രോബ്ലം ചെയ്യുമ്പോഴും ആദ്യം ആ ഫോം മെൻഷൻ ചെയ്യുക, ഓരോ സ്റ്റെപ്പിലും ഏത് ഫോം ആണെന്ന് മെൻഷൻ ചെയ്തിരിക്കണം. So it is limit x tends to 0, so 1 minus cos 3x by x square. Now this is in 0 by 0 form. So applying the L'Hospital rule, you will get limit x tends to 0 minus 3 sin 3x by 2x. Again it is in 0 by 0 form. Take the derivative once again. So that will be limit x tends to 0 9 cos 3x by 2 So that will be equal to 9 by 2. So the limit will be equal to 9 by 2.